1.4, Measuring Angles. Our objective in this lesson is to look at the measures of angles. First vocabulary word here. This is a definition of an angle. An angle is formed by two rays with the same endpoint. Okay, so we have an endpoint here, and then we have the two rays that come off of that endpoint. And we know that rays extend forever on to infinity. The rays are the sides of the angle, and the endpoint is the vertex of that angle. The vertex is a point. You know what a vertex is? It makes the corner, it makes the point there. We can name an angle in a number of ways. The first way is simply by its vertex. So this here would be angle A. Point A is the vertex. Now, this seems like a nice easy way to do it, but this is only if it is the only possible angle. And we'll talk a little bit more about that later. You can use this. It's not going to be as common as our next one, which is a point on each ray and the vertex. So this would be, we have a point on this ray and a point on this ray. We could call this angle, and notice we use the symbol for an angle in front of all of these. We are noting an angle, angle BAC, or just like in a segment, we can name it angle CAB. These two are the same angle. Now, the third way that we can name this angle is by a number. And so angle 1, we put a 1 on the interior of that angle, and this is simply for convenience. These last two here are the most common. This one here, the 3 letters, is going to be the most accurate. That should be the one we use most of the time. When we name angles using 3 points, the vertex must go in the middle. Notice here that we have angle BAC and angle CAB. The vertex must always go in the middle. We can use any point on those rays. The vertex will always be in the middle. All right. Here, interior of an angle is the stuff inside of it. The exterior of an angle is the stuff outside of it. That's pretty straightforward. Let's do our example here, naming angles. We want 2 other names for angle 1. So when we look at angle 1 here, we're looking at this angle right here. So we could name it angle JMK. Right? We're looking at this angle, JMK. We could also name it KMJ. Pause the video and answer the next 2 questions. All right, first one says, what are 2 other names for angle KML? So we're looking at the blue angle here, KML. We could also name that the other direction, LMK. And it handily has a little number in there, so we could call it angle 2. Now part B, hopefully you didn't try to name it angle M, because it says, would it be correct to name any of the angles angle M? The answer is no. There are 3 possible angles that could be identified if we just called it angle M. We can't tell which one. It could be angle 1 there, the purple one, angle 2, or it could be this whole big angle here, angle JML, and we have no idea which one we're talking about, so that is not appropriate. Again, the 3-letter names are the best way to be the most accurate. All right, make sure that you can name your angles, use the appropriate notation. Now we're going to talk about the size of an angle. We measure the size of an angle in degrees, at least in this book. When you get into higher math, you'll find other ways to do that. We can measure it in radians, which is a function of pi because it's a circle, but we don't have to worry about that. So we measure the size of an angle in degrees. To indicate the measure of an angle, we use a lowercase m in front of the angle symbol. So if we are talking about angle A and its measure is 62 degrees, we write the measure of angle A equals 62 degrees. Anytime you are talking about a number, you will have that m there. The measure of that angle is some number. Okay, you have used a protractor, I really hope, in previous math classes to measure angles. Our next postulate is the protractor postulate, and yes, it has a name. We like the ones with names. It says, consider ray OB. So we come over here to our diagram and we find ray OB. There's our ray. And a point A on one side of ray OB. So we're looking at this point. We can draw another ray, OA, to create an angle. Okay, and this angle, I don't know if I can draw in the middle here, measures around that way. And you know, you put your protractor, that center circle thingy goes right here on this point, and then there's lines to the side that we put on one of our rays, and that's how we measure an angle. What this postulate says is that every ray that we could possibly draw in here can be paired with a real number from 0 to 180. So we could go all the way around to a straight angle, straight line there. So we are simply saying that any ray that we could draw out from here, there's an infinite number of them in there, any ray, we can put a number on that. This is just a number line. A protractor is just a number line for angles. Okay? Hopefully you see that this is very similar to our ruler postulate. This allows us to find the measure of an angle. And the way that we do that is this formula right here. It is the measure of our angle is equal to the absolute value of point C minus point D, because we're just working on this circular number line and we are simply measuring how many degrees we have moved around that. And as we said, the protractor postulate is just the ruler postulate for angles. Let's go try some of these. Oh, not yet. We get to classify angles. This is good stuff here. Classifying angles is done according to their measures, and this should be reviewed. You know, an acute angle is between 0 and 90 degrees. A right angle is equal to 90 degrees, and notice right here, that symbol means right angle. That symbol right there indicates a right angle. An obtuse angle is between 90 degrees and 180 degrees, and a straight angle, this one might be new to us, a straight angle, which we know as a line, a straight angle measures 180 degrees. You're going to like this guy. We use that all the time. Straight angles are our friends. So know your angle classification. All right, now we get to do some examples. We want the measures of angle LKN, angle JKL, and angle JKN. So let's start with angle LKN. So we're going to go to our diagram, and I'm going to find point L, point K, and point N. So now one thing to notice on our protractor here is there are measures on the inside and on the outside. So you have to determine which direction you are measuring. So if you notice, if we're on the outside, 0, move the color here, 0 starts here and goes to 180 here. So if I'm measuring around the outside, this is 35 degrees, 0 degrees, 180 degrees. This is 90 degrees, and this is 145 degrees. Now if I'm measuring on the inside, this is 0 degrees, this is 35 degrees, this is still 90 degrees, that's handy. This is 145 degrees, and this is 180 degrees. So always make sure you know which direction you are measuring. So we're going to do angle LKN. So we need this right here. Are we going to go inside or outside? Well, let's use the inside and measure that direction. So we have the absolute value of our difference, 145 minus 0. So we get 145 degrees. And I don't care that the book does not put degree measures on. We do. We appropriately label all of our units. And a degree is a unit. And because it is between 90 and 180 degrees, our angle is obtuse. All right, let's look at the next one. JKL. So I find point J, point L, JKL. So I have to decide which direction I'm measuring. Let's go that way. Doesn't really matter. 90 minus 145. As long as I am using the same values, either inside or outside. What if we went on the outside on this one? So what if we did 90 minus 35? What's 90 minus 35? The absolute value of 55? Guess what? We end up with the same answer. Just make sure you are using the same, either inside or outside on both of your measurements. And angle JKN, so there's J, come down to K, and over to N. So we're measuring to there. 0 minus 90, that's a 90 degree angle. It is a right angle. Now the one above, 55, is between 0 and 90, so it's acute. All right, pause the video and do problem 2 there. All right, we just used our protractor postulate. Measure of angle LKH is 35 to 0. I found point L and point H, or you could use 180 and 145. You're still going to end up with 35 degrees and acute. HKN, H and N make our straight line there, so it's 180 minus 0 no matter which direction you go. 180 degrees is a straight angle, and MKH M is over here, H is over here. We can do 145 minus 0 or 180 minus 35. Either way, we get 145 degrees obtuse. All right, those are pretty easy. We'll look forward to doing those problems. Good stuff here. Angles with the same measure are congruent. Just like we had segments with the same length are congruent, angles with the same measure are congruent. So if our measure of angle A equals the measure of angle B, then angle A is congruent to angle B. If we're talking about congruency, we do not have measures in front of them. So our measures are equal. These are equal measure, gives us congruent angles. And of course, we have markings for our diagrams. We mark them with the same number of arcs. So this right here tells us that those angles are congruent. Now, let's look at something like this. Okay. These angles are congruent, and these angles are congruent, but blue and green are not congruent to each other. So my blue angles are congruent, my green angles are congruent. Notice how I used different numbers of arcs. Just like when we do segments, we use different numbers of tick marks. Let's do a problem using this. Synchronized swimmers form angles. Lots of things form angles. Hands on a clock form angles. We are told that the measure of angle GHJ is 90 degrees. So I am going to find angle GHJ. And I know that that measures 90 degrees. And look, there are 2 tick marks on it. Are there any other angles with the 2 arcs in there? Why, by golly, there is. This angle right here, angle KLM. So what do I know about those 2 angles? I know that angle GHJ is congruent to angle KLM because they both have those 2 arcs. So if my angles are congruent, my measures are equal. So because I know that this one is 90 degrees, I know that this one is also 90 degrees. Pause the video and do the next question. All right, that was a good one. We are told that the measure of angle ABC is 49 degrees. So I go and I find angle ABC. It's the one over here on the top left. And we label it 49 degrees. Now I notice that it has 1 arc mark. So I go and I look, and guess what? This other angle over here also has that arc mark, 1 arc on it. That tells me that those angles are congruent. So because angle ABC is congruent to angle FED, I know that their measures are equal. The measure of angle ABC equals the measure of angle FED, so therefore it is also 49 degrees. That was fun. And our postulate for this lesson. Angle addition postulate. This is another in our family of addition postulates, and we said that these are piece plus piece equals the whole. And this point B must be in the interior of our big angle, So we are making two angles here together. Then we know that the measure of angle AOB, that's this angle right here, plus the measure of angle BOC, that's that angle right there. Notice I did not mark them congruent, is going to equal the measure of our big angle here. Piece plus piece equals whole. We are just summing our angle measures. Let's look at a problem. If the measure of angle RQT, so the first thing I'm going to do, I am going to go find angle RQT. RQT is that angle right there. It is that whole thing. RQT is 155 degrees, so I label it. What are the measures of angles RQS and the measure of angle TQS? So let's find RQS. RQS goes right here, and TQS is right here. Well, I have two little angles that come together to make a big angle. So I can use my angle addition postulate to say that my two measures equal my third. The sum of my two measures equal my third. Then I simply substitute in my values, substitute in my measurements, do my math. I get x equals 23. That's not what I'm asked. I am asked to find the measures, so I substitute back in, and I get 72 degrees and 83 degrees. Well, let's check that. 72 plus 83, 155. We did good. All right. Pause the video and do the last problem here. All right. We are told that angle DEF is a straight angle. So I find angle DEF, and that's right there. And I know a straight angle means 180 degrees. So I label that. I want to know the measures of angle DEC and the measure of angle CEF. I can see that those two angles are pieces of my larger angle. So now I know that I am going to use my angle addition postulate, which says that the measures of the two smaller angles equal the measure of the larger angle. I substitute in my values, do my math, and I get x equals 14. That's not what I was asked for, though. I want to know the measures. So I take x and I substitute it back in because I know the measure of angle DEC is 11x minus 12. Do my math, I get the measure of angle DEC is 142 degrees. And then I want the measure of angle CEF, which I know is 2x plus 10. I substitute in my 14, and I get the measure of angle CEF is 38 degrees. And if I do a quick little check, I add those together, and why, yes, I get 180 degrees, which is what my large angle is. So I really believe that you can do really well on these problems. Just make sure that you are labeling everything on your diagrams. Look at your diagrams. That should be the first place you go. Make sure you are finding out where your points are, that you are labeling everything, and that you are writing with proper notation. And you need to say the words, or at least say them in your head as you go along. And enjoy the homework.